Assalamu alaikum. I hope you all are doing great. So today I will be telling you about the simulation of ultrasonic sensor, voltage sensor, current sensor, SD card and RTC on Proteus using Arduino Uno. Virtual terminal is basically a display that will be showing us the output of our sensor. So in order to place Arduino Uno ultrasonic sensor on a Proteus, first of all you should have to download their libraries from internet, their hex file, and to copy it into the library folder of the Proteus. Then you can place it over here. Let's get started with the ultrasonic sensor simulation first. First of all, you should know what an ultrasonic sensor is. Now, ultrasonic sensor is basically used to detect an object or an obstacle that is placed in front of it. Now, ultrasonic sensor has a trigger and an echo. Now, trigger is something that emits ultrasonic sound wave at 40 kilohertz, and this sound wave is deflected back by the object that is placed in front of it, and that sound wave is now received by an echo. Now when echo receives that sound wave, we get a specific value. By that value we can calculate the time taken by the sound wave and the distance, at what distance that obstacle or an object is. So in order to understand the working principle of ultrasonic sensor more easily, I have this data sheet of ultrasonic sensor as you can see on the screen. Now each sensor has its own data sheet. Now the data sheet tells us about the characteristic properties and working of the sensor. As you can see over here in electrical parameter, it is telling us that the working voltage of ultrasonic sensor is 5 volt. So we cannot apply more than 5 volt or less than 5 volt on the ultrasonic sensor. If we will do that, our sensor will not work properly and it may get burned and we will have to buy a new sensor. Now working current is 50 milliamps, working frequency 40 hertz, maximum range is 4 meters. So our sensor can detect an object or an obstacle up to the 4 meters. If it's far more than 4 meters, our sensor will not be able to detect it. And the maximum minimum range is 2 centimeters and measuring angle is 15 degrees. As you can see here in the figure, ultrasonic sensor, it has 4 pins. One pin is VCC, at which we apply the voltage. Other pin is trig, at which the trigger pin, and the other pin is echo pin, and the last pin is ground pin. So as you can see that, for example, an object is placed at 10 centimeter away from ultrasonic sensor. Now trigger emits the ultrasonic sound wave and it gets bounced back by the object and is being received by an echo. Now when trigger emits an ultrasonic sound wave for a very short interval of time, like for 10 microseconds, it generates 8 cycle of sonic burst. Now these sonic bursts travel in air, and if an object is in front of a sensor, it gets bounced back by that object and is being received by an echo. When the echo receives it, its wave can be seen that gets high. So that means echo have received a sound wave back, which tells him that there is an object or an obstacle placed in front of it. So now we know that speed of a sound is 340 meter per second. So time can be calculated by distance at which the object is present and divided by the speed of sound. So the distance is equal to time taken by the sound wave and into the speed of the sound. So now let me show you the code of the ultrasonic sensor. Here on the screen you can see the code of the ultrasonic sensor. Basically I have used trig pin name. Pin number 3 name is trig, which is used for the trigger of ultrasonic sensor, which is connected to the pin number 3 of Arduino, as you can see over here. Okay, now the echo pin is pin number 2, and now the pin mode of the trigger is output because it the pin would tell us about the thing that will be receiving or emitting something. Now trigger always emits ultrasonic sound wave, so its pin mode will be always output, and the pin mode for echo will be input because it will receive something from the outside. Now serial begin is used to start our data Now, first of all, in while loop we have used digital right trig law. It is used to make sure that our sensor is not working right now. It's off for a very short interval of time, like a delay is microseconds, only my 2 microseconds. Now after that I have set my sensor at high, which means that now my sensor is working. Now trigger will emit the ultrasonic sound wave. Now after the for the 10 microsecond. Now after 10 microsecond my trigger will be off. Now when the trigger emits the ultrasonic sound wave, it will travel in air, and if an object or obstacle is placed in front of it, it will get bounced back by that obstacle and echo will receive it. Now pulse in function basically help us to measure the time taken by the sound to receive when emitted through the trigger. So now I have set echo at high, so it will be receiving some ultrasonic sound wave when an obstacle is placed in front of the sensor, and the distance can be calculated by the formula as I have shown here, like 0.034 is the speed, and I have divided it by 2 because it will tell us the half cycle time taken by the ultrasonic sound wave. Okay, now the serial print is used to print, and it will print the value of our distance in centimeter, and it can be shown on the simulation I will show you. Now first of all, in order to simulate the ultrasonic sensor, you have to make sure that the hex file of the ultrasonic sensor is placed in it. Like over here I will show you again, this is the hex file of ultrasonic sensor and I have placed it, and okay. Now you have to run our code, like verify it. Now after verifying your code, you have to copy this thing. Okay, this is the link where is your hex file is of this code. Okay, once you copy it, you have to double click on Arduino, and then you have to paste it in the program file, and then okay. Now your simulation is ready. Now start the simulation. As you can see that our ultrasonic sensor is working. Now to see the output, I will show you the screen virtual terminal, which is telling us that 143 centimeter. Now this is a variable resistor that I have used, which is acting as an object that is placed in front of it. As I decrease its resistance, you can see that the distance is changing. First it was 133, now it's 122. If I decrease it more, it will be 110. Now if I increase it, the distance will keep on increasing. Okay, that's how the simulation of ultrasonic sensor is. Now I will stop it. Now I will be telling you about the simulation of voltage sensor. Over here you can see this circuit. Basically it's not a voltage sensor, but it is the internal circuit that is being used in voltage sensor. So I have drawn that circuit over here. So here is the source voltage, which is 10 volts. I am applying to this circuit. Here is a voltmeter to measure the voltage across these two resistors, R1 which is 10 kilo ohm and R2 which is 30 kilo ohm. And then there is a Zener diode and a capacitor. The reason I am using Zener diode and the capacitor over here is because of the Arduino. Like we know that Arduino just operate at 5 voltage. So now here you know that I'm supplying it at 10 voltage. So this voltage may get to the pin named voltage of the Arduino. As you can see that A2 is the pin named voltage. So if that 10 voltage reaches to the Arduino, our Arduino may get burned or will not work properly. So this capacitor keeps on getting charged through this voltage 10 volt that is being applied, and then Zener diode keeps on discharging this capacitor, because of which the 10 voltage doesn't reaches to the Arduino, and our Arduino works properly and fine. So the principle of this circuit is basically dependent upon this simple one formula, which is known as voltage divider formula, which means that the output voltage is equal to the resistance R2 divided by the sum of resistance of R1 and R2 into the applied voltage V in. So you know that applied voltage is 10 volts, and R2 is 30 kilo ohm and R1 is 10 kilo ohm. So by putting values we can calculate the voltage. So now let me show you the code that I have made for this sensor over here. The constant or floats are the data type here. Voltage sensor is the name of the pin number A2 of Arduino. As you can see that A2, I have named it as a voltage sensor in our code. Then the resistance or R2 is 30 kilo ohm and R1 is 10 kilo ohm. Now serial dot begin is used for the speed of the input and output for the Arduino to calculate it. Now the pin mode of the voltage sensor is input. Because this A2 will be taking an input from this circuit and will be giving to the Arduino. When it will be given to the Arduino, then the Arduino will be telling us that how much of voltage is being measured across these two resistors. That is the reason why I have set this pin mode as an input. Now as you can see that here I have used a new variable which is named as value, which will read the value that is being measured by the pin number A2 of the Arduino, which is named as voltage. When the circuit will run, this 10 voltage will apply, and then there will be some voltage difference across these two resistors, and that voltage difference will become recorded by or measured by this the voltage pin of the Arduino, and then this value will be equal to the value variable that I have declared in the uh, code. Now, in order to calculate the actual voltage, I will be using that value and the voltage divider. Now, that value is being used as the input voltage source that I have supplied as a 10 volt, and here is a voltage divider. As you can see, this thing, the 5.02 divided by 628, it is used to convert the analog reading of the Arduino into the digital. That's why I've used it, and then simply you will print the voltage value. Now first let me show you how to verify the code. As you can see that my code is verified. Now you have to copy this thing. Okay, it's the hex file of your code. Once you copy it, you have to double click on Arduino and you have to place it over here in program file. Once you place it, then click on OK, and now start simulation. Once you start simulation, now you can see that the voltmeter is measuring 10 volts across these two resistors, and as you can see on the screen of virtual terminal, it is also giving us the 10 volts. Let me pause it. Here you can see that 10 volts are being measured, so it means that our sensor is working correctly and perfectly. So now I will be telling you how to simulate current sensor on a Proteus while using Arduino Uno. Over here, as you can see, current sensor, it is connected with ammeter, motor and the capacitor. Now VCC pin is connected with the voltage source that we are giving to the sensor. Make sure that it is 5 volts, not more than 5 volts. If it is more than 5 volts, our sensor may get damaged and may not work properly. And remember that current sensor is very sensitive, so you have to be very careful. Make sure before applying a voltage on a current sensor, make sure that it is 5 volts. Now VI out will basically give us the current that is being measured by this sensor, and that current will be given to the Arduino pin number A1, analog pin A1. As you can see, they are connected. Now that measured current value will be given to the Arduino, and we will use it to measure the actual current that our sensor is measuring. Later in code I will explain it to you. Now the reason I have connected this ammeter over here is to make sure that the value that our current sensor is measuring is correct or not, to cross check our values, like when this motor will rotate, it will draw some current, and this sensor will be measuring that current, no doubt. And this ammeter will also measure that current that is being drawn by this motor. So in order to make sure that my sensor work properly and perfectly, I have attached the ammeter with it. Now the filter pin is basically used to filter the noises from the current sensor. As you know that current sensor is very sensitive, as I have said earlier, so the noises can be generated in a current sensor due to many reasons. Maybe because of the loose wire that you have attached in a circuit, or maybe because of the voltage difference. There can be many reasons about it. So let me show you the data sheet of a current sensor over here. you can see the data sheet of a current sensor. Okay, now it shows us the sensitivity of a current sensor that I'm using, ACS712ELCTR/05P/T. It has an optimized range of plus minus 5 amps and a sensitivity of 185. Later I will be subtracting using this sensitivity in a code to make sure that the value I am getting from the sensor is correct or not. As you know that the final output of the current sensor is like this clear wave. It is because it is being filtered. If we will not use the filter of the current sensor, then we will get many distortions in this wave. That is the reason I am using this capacitor attached with the filter of the current sensor to make sure that it works properly. So now let me show you the code of the current sensor that I have written over here. Look, as you can see that these are the variables that I have declared and the data type is float. I will be using them to calculate the current, correct value of the current. A1 is the pin number of the Arduino to whom I have named as a current sensor over here in my code. Now these are the variables that I am using for the filtering purposes. As I have said that current sensor is very sensitive, so we have to filter all the noises to get an accurate reading. Now serial dot begin 9600 will begin the Arduino functioning. The pin mode is output because the sensor will giving us the out value of that current and we will be taking it in the Arduino pin. So to make sure that it works properly, first of all I am taking a 10 readings. These lines are telling that I'm taking the 10 readings and taking their average and taking that next 10 readings and their average and so on to make sure that I get an accurate value of the current. Now you know that over here I have used the if condition. Now this if condition means that if the reading number is greater than 10, the reading should start from 0. Over here I have made an array of a smooth. Okay, basically smooth is an array that will be measuring the readings of 10 different readings of a current sensor in it. Then it will take an average of it. As you can see I am taking an average in the next line, and then we will convert that value into the voltage. Now in order to convert that value into the voltage, we are multiplying it by 5 and dividing by 1024. The reason we are doing this is because to convert an analog value of Arduino into digital we have to do this thing. Okay, now after that the current is equal to converted voltage divided by 0.2720. It is because the formula that we know that current is equal to VIR. So there is a little resistance that we are using and measuring current. Now serial.print is equal to current value. It will print the current value on the serial monitor, and there you go. That's the code and how it works. Now let me verify my code. Once it's done verifying, you have to copy this thing again. Once you copy it, now you have to double click on the Arduino and then paste it over here, and okay, now you have to simulate it. Once you simulate it, as you can see that my sensor is working properly and motor is working and it is drawing a current of 9.17 amps. Now to check that if my sensor is giving a correct reading or not, I will show you the screen of the virtual terminal that will show me the value of the current that is being measured by our sensor. As you can see, let me pause it. As you can see, the sensor is giving us the value as same as our ammeter, so that means that our sensor is working. So now let me show you one thing. If you go up above, you see that these readings, these are not 9.17, these are different readings starting from negative. So these are basically the noises that were generated in the current sensor. So when I used that code, the code where I was calculating the average, so by calculating the average again and again of the 10 readings, I finally got the correct reading, which was 9.17, and my sensor started to give me the correct reading of 9.17, as you can see at the ammeter. Now let me stop it. So now I will be telling you how to simulate SD card and RTC, which is real-time clock, on a Proteus using Arduino Uno. Basically, you know that what is the purpose of SD card, like it is used to store data in it, like it is used in our mobile phones to store data, pictures or song or whatever type of data you want to store in it. Now real-time clock is something that will be telling us about the time and date of today, like right now what is the time and what is the date. That will be told to us by the real-time clock. To make it all happen, I have to write an extensive code for both of them. Now let me show you the code that I have written for them. As you can see on the screen right now, I'm showing you the code of the SD card and RTC. First of all, I have included the three libraries. If you will not include these three libraries, your code will not work properly. So make sure that you have these libraries or include them in the code. If you don't have these libraries, please download them. Now after that, I have declared the variable. Okay, after declaring the variable in void setup, I have put st.begin, rtc.begin and var.begin. Now what these things do? Actually st.begin puts the SD card into the start mode or in the working mode, you can say in simple words. Similar for the RTC, and var.begin actually set the explicit date and time format for the RTC. Now after that, I have declared a pin mode CS input. Actually it is a pin of a SD card CS. I have declared it as an input because it will be taking data from RTC and we will be storing that data into the SD card, and then we will be later showing that how the data is saved in that file and how we can access that file to see what data is being stored on the SD card. Now over here I have simply used the if else condition for SD card and RTC. As you can see that I have put if RTC dot begin. If this statement is true, then print that RTC initialized. If this statement is false, then print RTC failed. Now the reason why I have used this condition is because to make sure that my SD card and RTC are in the working mode when I have entered the command rtc.begin above. In order to make sure that my SD card and RTC are working, so I have put this command. If my RTC or SD card is not working, then it will say that RTC failed and SD card failed. So after that, in while loop you can see that this line I have put that date time now is equal to RTC. Now basically this date time is a function that will be assigning the today date and time of my laptop to the RTC. Okay, now RTC will be storing that date and time in the SD card, and SD card will be storing that date and time in a specific file that I have created in it, and later we will access it and open it to see that if the uh, date and time or the thing that we were storing or the data that we were storing in the SD card is or there or not. Then simply I have printing the hour, minute, second, day, month and year, and this line I have added to make sure that my SD card and RTC are working. Now as you can see that IMS file is a variable in which I have which is assigned that sd.open. Now what it will do, it will open the SD card and will create a file named sdcard.txt with an extension of txt, and the file write means that we are going to write data in it. It means that the data that RTC is showing us the date and time will be storing that date and time into this file named sdcard.txt in the SD card. Now as you can see that I have simply write that name of the file and I have printing this data that I want to store into the SD card. Now after that I have used an if else condition to make sure that my data is being saved in SD card or not. If the data is being saved, it will tell me at the end that the data is saved. But if the data is not being saved or there is some error in it, it will show me that error in opening SD card.txt, or if the file is not created in the SD card. Now let me verify it once. As you can see the compiling is done. Now you have to copy this line again. Okay, now after copying it, you have to double click on the SD card and you have to paste it over here and then click on OK and then run the simulation. Now once the simulation is run, you will see that the real-time clock and SD card are working. Now let me show you the data on the virtual terminal. As you can see on the virtual terminal, it showed me that initialization checkup is happening, that RTC is initialized and SD card is also been initialized. So the program started and this is the time right now and this is the day. As you can see over here on my laptop, look, 6:29. It is actually showing us the time in 18 or 24 hours, which is 18:28:45 is the second, and 23/6/2020, which is the date right now. Now let me show you the RTC screen. As you can see, this is a real-time clock. It is telling us that what is the time, what is the date, and it is even telling us the second, like 1 second past, 2 second past. Now, how we can access the data which we are storing in the SD card? To do that, you have to pause your simulation. After you pause your simulation, go to the debug and click on the memory card contents. Once you click it, the file name, you remember I created it with the name sdcard.txt. Now export that file on the desktop as I am doing it. Now just minimize it and open it. As you can see, we have a file over here named SD card, which is the txt with the extension. Now I will open it. Now as you can see that the data that I was storing on it is same as the data that was being printed on the virtual terminal screen. So now what I did is actually first I simulated all the sensors separately and showed you that they are working properly and their codes. Now what I did is actually put those code all together into the one program, and I have created a one code for every one of them, and we will run this code and check if our sensors are working properly or not. As you can see, I have included the libraries, then I have declared the variables, then as you can see in void setup, I have declared the pin modes and the if else condition to check if my RTC SD card is working or not. Then as you can see in void loop, I have just called the print functions and the datetime function. Now the reason is that actually I have created the sub functions for the ultrasonic sensor and the voltage sensor and current sensor. Now these sub functions contain all the program that we need to measure the distance or to measure the voltage in voltage sensor and to measure the current in current sensor, as you can see. So now what I will be doing is just calling the names of these functions into the main program when I need to calculate their current or when I need to calculate the voltage or when I need to calculate the distance. As you can see that in while loop, here I have called the ultrasonic function, and then after calling it I am printing it, and after that I have called the current sensing function and I am printing the value of current. That's how it works. Okay, now my code will work efficiently and smoothly, and similarly I have created the INS file and I am storing all the results like date and time of the RTC and the distance measured by ultrasonic sensor and the value of current being measured by the current sensor and the voltage measured being by the voltage sensor. Now let's verify it first. As you can see that it has been verified successfully, so now we will copy this line. Once it's copied, we will double click on Arduino, we will paste it over here. After pasting it over here, we will run the simulation. Now it may take some. Now as you can see that the simulation is working and the value is being measured. Let me show you at the screen of RTC clock. Now RTC clock is basically telling us the time. As you can see right now it's 1901, so it's gonna be 1901 soon. Okay, let me pause it for a moment. So now here you can see that the voltage value is 10 volts, as you can see over here on the voltmeter, and the current value is 9.17, as you can see on the amp meter, it's 9.17. That means that our sensors are working properly, and the distance being measured by the ultrasonic sensor is 142. So now I will show you that the data which is being saved on the SD card, how we can access it. We will pause it, go to the debug, memory card contents, and export this file named SD card. After exporting it, we will open it. Here you can see that the results are matching, with the output that were being shown on the terminal screen, virtual terminal screen, as you can see that. So that's our project. I hope you enjoyed watching it. Give us a big thumbs up and comments. If you have any questions about my project, I will happily answer them.